Hi everyone, and welcome back to another session of IGCSE math preparation. My name is Irfan, and today we're going to talk about money and finance. As you know, this is covered in IGCSE math classes. The first thing that you need to know about money is how to convert different currencies to one another. So the type of question that you might come across in the exam is that you will be provided some information, probably a table, that different currencies are given. So let's say the today's rate for euro is, so if this is euro, so if you pay €1, you're gonna get 1.3 US dollar in return. Okay, and maybe I can use another currency, the Kuwait dinar. So if you give €1, you will get 0.4 Kuwait dinar. That's quite a strong currency. If I'm not mistaken, that's the strongest in the world. So, and let's do one more. Let's change it to US dollars. So $1 gives you or buys you 4.2 Malaysian ringgit. All right, that's enough. So let's do some conversion. Let's say you have, let's just start with some easy questions. Let's say you have 400 US dollar in your pocket and you want to convert it to Malaysian ringgit. How many ringgits you can get in return? Well, this is just a matter of multiplication, right? You know the rate, you just have to multiply it by 4.2, that's all. And you get the answer in ringgit, 618, yeah, 1,680. And let's say you have, let's make it a little bit harder. Let's say you have 1,200 dinar in your pocket. So how much dollar you can buy with that? Maybe we do euro first, that's easier. Let's do euro. How much euro you can buy with that? And then the next question is how much dollar you can buy with that. So for euro, what you need to know, you have the rate here, right? That's given to you. So €1 buys you basically 0.4 dinar. Now, this is the matter of division, not multiplication anymore, right? So because you're calculating in reverse, so you have to divide it by 0.4. And if you do that, you get 3K, right? 3,000 euro with this current rate. Yeah, this is the today's rate. Now, for dollar, we don't have the exact rate, I mean the direct rate that converts dollar to dinar. However, there is a connection between euro and dinar and euro and dollar. So we have already calculated how much euro we can get with 1,200 dinar. Now, if you want to find for US dollar, just multiply it by 1.3. That's all. So how much does that give you? $3,900. So, however, if the question didn't ask you to find euro first, so basically this path was not there. If they ask you directly to convert from dinar to US dollar, so you know that you should divide it by 0.4 and then multiply it by 1.3. In other words, you can multiply it directly by this fraction, 1.3 over 0.4. So this should gives you in US dollar directly. So this is one type of question that you come across. Before I get into the interest and the fun parts of finance, there are some terminology that I have to define to you guys. So the first thing, let's say if all the amount of money that is generated, if we call it gross pay. So that's all the money that has been generated. So net pay is obtained after you deduct all the taxes, all the insurance, what else? The pension, right? So after you deduct all these things, you get what we call net pay, right? So that's one term right there. Then we have bonus. Sometimes you get money added to your basic salary. So if this is your basic salary, and maybe this month you do a good job and your boss decides to give you some bonus, so anything added to this, it's called bonus. And then sometimes you work overtime, and for that you're expecting to get paid at a higher rate, right? You get basic salary for the fixed number of hours, right? Fixed number of hours. And anything more than this, so we call it overtime. And for that, you're not gonna get the same payment. Sometimes you get double, or sometimes you get what we call 1.5 or time and a half. So time and a half means multiplied by 1.5, or double time, it means multiplied by 2. So this is time and a half. So this is double time. All right. And then lastly, we have piecework. So piecework occurs when you get paid not based on the time or the number of hours that you work, but you get paid based on the task that you deliver. For example, you're a worker in a pottery factory. So your boss tells you every pot that you make, you get $2 for it. So at the end of the day, if you make tens of it, you get $20. So that's what we call piecework, or based on the articles that you make. Let's do one question regarding this. Miss Martinez works 38 hours and the hourly rate is $4.15. So that's the hourly rate that she's getting paid. She decides to work 6 hours overtime, and the rate for that is time and a half. It's not double, it's time and a half. So once you see this phrase, you know what you need to do. You just have to multiply it by 1.5. So they're asking, what is the total gross pay? So that would be the gross pay. And what is the net pay if we have 32% deduction? So after this, what is the net pay basically? So it seems quite an easy question, and to be frank, it is actually, because the gross pay, all you need to do is just multiply 38 by, this is the number of fixed hours, right? The fixed hours, and you multiply it by 4.15, and then you add the overtime that you work. However, you can't give it the same rate as basic salary. You need to multiply 4.15 by 1.5. That's, we've been told, time and a half. And how many of these we have? 6 hours. So you do the calculation, you get the final answer, 157.70 cents. And for this one, we get 37.35, which if I add them up together, at the end, I get 195.05 cents, right? So that's the gross pay. However, the net pay, which they're asking, if you recall from percentages, there are two ways you can actually find the net pay. You can find how much is the deduction, and then you deduct it from this amount, or you can apply the formula that I have given you on previous video and find the answer directly, meaning which you write the old amount or old price on the left hand side, if you recall, and in the bracket you just put 100 minus 32, and here's the so on the right hand side it gives you the new amount, which is the net pay, right? So if I do that, the answer would be 132, and you can round it to 63. That is sufficient enough. That would be in dollar, of course. Okay, that's it. This is the type of question that you might get. Finding the net pay, just remember you have to deduct everything such as the taxes, insurance, and the pension. So the next topic would be profit and loss. What is profit and loss? So whenever you want to produce any product, it could be food stuff or anything, it's going to cost you something. So there is a manufacturing cost, right? Manufacturing cost. And since you have added value to those raw materials, you're definitely expecting to sell it higher than what it costs you initially, right? For example, it costs you $2, but you're gonna sell it $3. And that would be the selling price. Now, if the selling price is more than the manufacturing cost, which usually that's the case, you have made profit. So in this case, the profit is $1. However, let's say it cost you originally $2, but due to any reason, maybe the demand is not that high, or the situation in the market is not that good, so you end up selling it 1.8 or $1.80. So if the selling price is less than the manufacturing cost, which in this case it is, the loss, we have loss, and in this case it is 20 cents or $0.2, right? And usually we express the profit and loss as percentage. So they don't ask you, it's very simple if they ask you like that. However, if they ask you as percentage, you know what you have to do. If you recall from the percentage chapter, you need to divide your profit or loss by, so profit or loss by the cost price, and then multiply it by 100 at the end, right? So an easy example, let's say a company manufactures electrical items for kitchen, like a fridge, and the cost price or the manufacturing cost, in short CP, for that fridge is $50, and the selling price is $65. So they're asking you how much is the profit, find the percentage profit. So what you have to do is basically to find the profit first, which is 15, right? You have to find the profit first, selling price minus cost price, and then divide it by 50, and you multiply the answer by 100, and that would give you 30% in this case, right? So as easy as that. The last topic is about interest. And we have two types of interests. The first one, which is quite an easy one, it's called simple interest. And by the way, what is an interest? Interest is the money that banks add to your original money, the money that you have deposited in the bank in your account for a fixed period of time. So there will be some money added to it. That money, we call it interest. Okay. Now there are two ways they can do this. One is simple interest. Okay, so for you to understand it better what it is, let me demonstrate it on, so let's say this is money and this is time. So this is 0. I can use a histogram. So time is in year. So on yearly basis, for example. So let's say the first year you deposit, let's choose an easy number to work with, 100 US dollar. So that's US dollar. 100 US dollar, you deposit the money. So at the end of the year, if the interest is 10%, the interest rate is 10%. So you're expecting $10 to be added to your money. So this is your deposit, or the more professional term to use is principal, right? After 1 year, this is what you have in your bank account. You still have your deposit plus the 10% of that, which is basically $10 in this case. 10% of 100 is $10, right? And then again, if you leave your money in the bank for the third year, what you're gonna get is another basically $10. So you still have that 10 US dollar that you got it in year 2. So I have to draw 2 of these. Okay, one is this, the other one. So that would add up to 20 in total. So this is 10, this is 10, and this is also 10, right? So here you had 100 originally, right? And now you have 110, and now you have 120, right? So basically they go all the way back to what you have deposited. They calculate 10% of it, and they keep adding it every year until you withdraw any money out of your bank account. So this is called simple interest, and the equation is quite easy to work with. The formula is, this is how you write it. The SI, or the simple interest, is equal to PTR over 100. So that's the most important formula that you have to learn when it comes to interests. There is another one, compound interest, which we will get to it in a minute. Now, what is P? P is principal, this guy right here. T is the time. So usually, since it's in yearly basis, or the annual, it's annually, it is calculated annually. So we don't need to make any conversion if it is given in years. Unless it's given in months, then you have to do some conversion there. And then the R represent the rate, which is usually also counted in yearly basis. So that's the annual rate, so AR sometimes. And this is the principal. And what else? This is a simple interest, and 100 is 100. So now we have 4 variables: the simple interest, principal, time, and the rate. So usually 3 of them is given to you, and the 4th one you have to calculate. An example of this formula would be a scenario where they're asking for R, the interest rate. The interest is given. They say you deposit 200 US dollar for 2 years, and at the end of 2 years you have 50 US dollar simple interest, added to your money. So basically at the end of the second year, you have 250 in your account. They asking for the interest rate. They asking how much was the interest rate annually. So you know the equation for simple interest. All you have to do is just substitute everything and look for R. You have to make R the subject of the equation here. And if you do that, R is equal to 100 times SI over P times T. With a simple matter of substitution, you get 50. Principal is 200 and time is 2 years. So you would get 12.5. So that's the rate, the annual rate in percentage, of course. The last topic for finance would be compound interest. So what is compound interest and how does it differ with simple interest? Sometimes when I think it's better if I demonstrate it again on an histogram just to show you. This is the time basis. This is 1, 2, 4. Okay. So for better comparison, I'm gonna deposit 100 US dollar again in my bank account. So that's what I have, left it for 1 year. So let's say the interest rate again is 10%, right? And if this is your principal, at the end of the year 1, you're expecting to receive 10% off 100, which is 10 US dollar. So that would be added to your principal money, that is 100. So you have now 110, right? So that's your expectation. So this is 110 now. So this is 100 initially, that's what it was. Now the third year, what happens is you still have your principal, you still have the 10% which was added for the first year, but now the interest, instead of each time they calculate the 10% of the money that you have deposited, you will get interest on the interest as well. So interest doesn't just count it based on the principal, but it is also on the interest itself. So they go and calculate 10% of this money, right, which is 110, and they add it to third year. So 10% of 110, that would be 11, right? So you have $11 here, and you had $10 first, and now the money is 121. And compared to simple interest, this money was 120 if we were supposed to calculate it for simple interest, right? However, for compound interest, so this is compound interest, you get $121. The difference is not much now, but as we go further and further, it grows more and more. For example, for the fourth year, you still have that 100. You still that the 100 that you receive on year 1, at the end of year 1, the one that you receive at the end of year 2, the $11, you still have that. Now, the fourth year, you're gonna get 10% of what you had in your account on year 3. So now they're gonna calculate 10% of this, which is 10% of $121, and that would be 12 $1.10, and that will be added to your account, and now you have a total of 133 and 10 cent, right? That's how much you have. And as a comparison, if it was simple interest, here we had 130. Now you see the difference is getting bigger and bigger. Here there was no difference for year one, right? At the end of year one or on the second year. Here the difference is just one. So maybe I can use another color to show the difference. Here there is no difference if it was simple or compound. However, we have a difference of $1 here, here $3.1, and it keeps growing, right? And that's actually what happens in our bank account. They don't count it on based on simple interest. They give us the compound interest, which is more beneficial. Now, what is the associated equation with compound interest? The symbol that we use to show compound interest is I. So that's the interest, right? That's the interest or the money added. And you multiply the principal that you have deposited. This is your principal, right? And you multiply it by 1 plus r over 100 raised to the power of n, which n represent time here, and you subtract it by the principal again, right? Because sometimes the question is interested in finding the interest only, meaning which they say at the end of the year 4, how much interest is added to your principal. So they're basically interested in this amount, which is 33.1, or sometimes they say how much money you have at the end of year 4, which is this much, right? So if they're asking for the total money in your account, you don't need to subtract P, and this is the total money. So this part is the total money in your account. And if you subtract the principal, if you exclude it, then you get the pure interest that is added to your money. So let's do a couple of questions. So this is the difference between simple interest and compound interest, because for simple interest, this guy right here directly would give us the interest, right? We didn't need to subtract nor add anything at the end. However, if in the questions they ask us what is the total money in your account after, for example, 3 or 4 years, then you had to add the principal as well, because this formula, this only gives you the interest, unlike the compound interest formula. So you just take a minute and try to digest the difference here. So this is where the usually the students, they get confused. And the questions, they're not that difficult. Let me do 2 questions, one quite easy, the other one a bit tricky. We have a school which increases its intake by 10% each year. By the way, this formula, it can also be used not just for finance, for other scenarios as well. You will see what I mean by that. So school increases its intake by 10% each year. If it starts with 1,000 students, how many will it have at the beginning of the 4th year of expansion? So even though here we're not dealing with money, but the equation, the formula that I'm gonna use is the compound interest formula. Why? Because the intake in this school is increased 10% each year. So it's not the 10% of the first year, right? If they say the 10% of the first year, so now we have 1,000 students, and every year it is added 10% of this. So next year, meaning which we have 1,100 students, and the next year we have 1,200 students, right? So this is the first, second, third. However, this is not the case, right? This is the simple interest. What they're saying is that the intake increases by 10% each year. So meaning which for the first year, of course, it is still 1,100, but the third year, at the end of second year or on third year, so you multiply this by 10%. So which gives you 1,210. So you see the difference? This is the compound and this is the simple, right? However, this would be tedious task to do if you want to continue like that, and otherwise I wouldn't give you the formula, right? So this is not professional way to solve this. However, I just wanted to show you and compare what would happen if we have done this, if you have solved this question using simple interest, and what's the difference with the other approach, which is compound. Now they're saying fourth year. So you know the equation, and that would be I is equal to P times 1 plus R over 100. The time, that would be N minus P. So this, again, I should remind you, this gives you, in this case, the number of students added at the end of, on fourth year, right? On fourth year. So, but we're looking at the total number of students, right? At the beginning of the fourth year, right? Here at the beginning. So I should not subtract P by it, right? And this one is not I anymore. Maybe I can say total students. Now, what is N? N is time. So I should key in actually at the end of at the beginning of fourth. So it means I substitute 3. Okay. I repeat, they say at the beginning of fourth year. So it means after 3 years, right? So this is 1, 2, 3. All right, so I hope it's clear. Maybe it was better I start from 0, 1, 2, 3, so you wouldn't be confused. But this shouldn't, you shouldn't put 4 here, guys. They say at the beginning of fourth year, meaning which after 3 years completed. Okay, so therefore I put 3 here. R is 10%, right? So I just put 10, R is 10 here. So, and P is basically 1,000 students. And you can solve this. All you have to do is just multiply 1,000 by 1.1 raised to the power of 3, because this is 0.1. And when you add 1, you get 1.1 raised to the power of 3. And you can key in your calculator, and the answer would be 1,331 students. So the number here would be 1331. Okay. Now, if they were interested that compared to the first year, how many students are added, then you subtract the 1,000 again, and that gives you 331 students are new, are added compared to the first year, right? But that's not what they want. So you have to be careful when you exclude it or when you include it, okay? So I'm gonna erase everything here, and that's it. Maybe we can do one tricky question. How many years will it take for a debt to double at 15% per annual compound interest, right? So this is basically yearly basis per annual. And we know that they're talking about the compound interest. As you can see, the principal is not given. We do not have any numerical value for our principal. So what they say, whatever it was initially, right? Let's call it X. Now, after how many years it becomes 2X? Well, approximately 2X, not exactly 2X, but approximately becomes double of what you have invested. Given that this is our interest rate, well, what you need to do, because if you recall from the compound interest, this was our equation, 1 plus r over 100 times n. So this part right now, if r is 15, so if you replace 15 here, so this whole bracket becomes 1.15, and this n means you have to keep multiplying it by itself until p, when p is multiplied by that, this become approximately 2p, right? So that's basically the idea. So if you take p to be 1, right? So on the right hand side, we want approximately to reach 2, make it double, right? So what you need to do is to key in 1.15 in your calculator and then keep multiplying by 1.15, or you can do it once and then after that you keep pressing the equal key, right? In some calculator that works as well. And if you do that, so I'm pressing once, I get 1.32, and then I press it another time, I get 1.52, one more time 1.74, one more time 2.01. So that's where I stop, right? And then you count that how many times you press the equal button, or how many times you multiply that. So in this case, I have actually multiplied 4 times. We go all the way till 1, 1, and then 2, and then 3, and then 4, right? So that would be 4 years, right? So because they say the per annual, so that would be after 4 years. However, for those who are taking add math, they will learn an easier way to solve this equation, and that would be using logarithms. So I didn't mention that here because the IGCSE math student, they don't learn logarithms. That's not in the syllabus. So the only approach which is left for us guys is to do this. However, for add math students, what you can do, you can form this equation, and then p is cancelled right away from both sides, and r, if you substitute r to be 15, so basically you're looking for, you have to solve an exponential equation which looks something like this. N is our unknown, and math students, they don't know how to answer this type of question because they know what exponential equation is, but since the base on both sides is not the same, so they don't know what to do. However, if you study add math, you know that you can take logarithm or natural log from both sides, and therefore n can be found easily by dividing ln2 over ln 1.15, and you get the same answer, right? So this is, but you don't need to bother with this part. This is for add math students. All right, but however, you can, any type of question similar to this is the approach. Maybe we do one more this time. let's do an example of depreciation, like a value of a car which drops 27% each year. So it's a car loses value at this rate. And again, they're asking you, how long will it take? How many years will it take for its value to drops to half? So again, we do not know the initial value of the car, and actually we don't need it. So if you form the formula, this is what you have to do. So since it's loss or depreciation, make sure you put negative here, 27 over 100 raised to the power of n. You want it to become half of p. Again, math students easily, they can solve this using logarithms. However, for math students, they can multiply 73, I'm sorry, yeah, 0.73 or 73% by itself until you get you approach to half. So I don't know how many times we have to do that. Let's take our calculator and do it together. And I press it once, I get half right away. So this is almost half, right? So that's it. We stop there and no need to continue any further. If you key in one more time, if you press in one more time, you get 0.38, but they specifically mentioned they want half of the initial value. So basically after 0 point, when you multiply it once, let me see, 1 times 0.7, okay, then one more time, I'm sorry, 2 times, yeah, not 1 time, but 2 times, so it's 2 years, okay, so 2 years. And I think I have made a mistake in this question as well. Yeah, I forgot to calculate the first multiplication. Guys, I'm afraid the answer here is 5 years. So yeah, I don't know why I missed out the first year. So when you multiply 1 by 1.15 and then you keep pressing that, 2, 3, 4, 5, yes, that is 5 years. So this is after 1 year, 2, 3, 4, 5. Okay, yeah, having said that, we're done with money and finance. Wait for the future videos, which we will do some past year paper questions regarding this chapter. Thank you very much. Stay safe, and I'll see you guys in the future videos.